So we left off in Chapter 4 with quadratic equations, and in Chapter 5 we talk about how to change from one form of the quadratic equation to the other. So we first start going from factored form to standard form by expanding. For example, if we were given the expression y equals 2 bracket 3x minus 4 bracket x plus 1, how do we change that into standard form? When we are expanding, we have to make sure that we are expanding properly, that we're not multiplying a term more than once. So we're multiplying the 2, for example, into the first bracket. If we do that first, we're copying down the second bracket as it was, and then we're continuing on to solve the rest of the question. If you don't want to multiply the 2 into the first bracket first using the distributive property, you can also leave the 2 and you can do FOIL first, which means you're multiplying the 2 brackets by each other and then leaving the 2 until the end. FOIL is multiplying the first term in each bracket, then the outside terms, then the inside terms, and then the last terms together. It's basically doing the distributive property 2 times in a row. So if you used FOIL first, which I believe most of you have, then you're going to end up with 3x squared plus 3x minus 4x minus 4. When you use FOIL, anytime you use FOIL to expand, you have to simplify the 2 middle terms, which are like terms. So we have 2 bracket 3x squared, 3 take away 4 is negative 1. So minus x is your middle term. And then lastly, you're going to use the distributive property to multiply that 2 by each of the terms in the brackets. So your equation in standard form then is 6x squared minus 2x minus 8. So basically the first majority of that chapter 5 beginning was using either distributive property or using FOIL to expand. Remember that if you're expanding a binomial square, for example, if you're expanding an expression such as 2x minus 4, I shouldn't make it minus 4, 2x minus 5 squared, that means you're actually doing 2x minus 5 times 2x minus 5. So either you can write the brackets out twice and you can use FOIL, or if you want to take a shortcut, you can use the binomial square property. Recall that using the binomial square property means that we square the first term. So 2x times itself is 4x squared. We square the last term, so negative 5 times negative 5 is positive 25. And the middle term is just the product of the 2 terms in the bracket, so 2x times negative 5, which gives me negative 10x. Then we double that to get negative 20x. So that's just the binomial square property. It's a quick way of expanding the squared bracket by squaring the first term. This squared is 4x squared. Squaring the last term, negative 5 times negative 5 is 25. And to get the 20x, you're just going to do 2x times negative 5, and then you're going to double it. Okay, so that is most of expanding. The expanding questions, some of them involved square guarding questions. You can review those in your notes as well. Most of the beginning part of Chapter 5 was just expanding questions like the ones we've just done. The second part of Chapter 5 involved going backwards. So instead of going from factored form to standard form, now we're going to go backwards and go from standard to factored form. So let's give an example here. And we'll talk about the different types of factoring. The types of factoring you've learned so far, you've learned common factoring, you've learned factoring trinomials, and there were 3 types of trinomials. There was a perfect square trinomial, there was a simple trinomial, and a complex trinomial. And you also learned how to factor a difference of squares. Difference of squares. So we'll do an example of each of those just to remind you how to factor, and we'll talk about solving by factoring, because when we have questions like this, a lot of the time the reason you're factoring is to find the roots or find the x-intercepts. So let's do a couple examples. In the first question, we're going to factor fully, and it's going to involve a common factoring question and a trinomial. So we're going to do negative 3x squared minus 12x plus 36. That's an equation in standard form. What we know about the parabola right now, we know that it opens down. We know it's stretched vertically by a factor of 3. And we know it has a y-intercept of positive 36. So It's either on the left or the right-hand side, and it goes downward. To get the rest of the equation, to get the roots and to show where the vertex could be, we have to factor this one. So when we're looking at the equation, we first ask ourselves, is there a common factor? That's our very first step. In this case, the common factor is the a value, which is -3. If ever that first term is negative, you want to take out a negative common factor. Sometimes it might even just be -1, and there might not be a 3 there. But you're still going to take the negative number out in front of the set of brackets. Remember, when you're common factoring, it means you're going to divide each of the terms by your greatest common factor. So divide each one by -3 in this case to get what's left in the brackets. X squared, negative divided by negative, be careful, is a positive 4x, and -12. So that's just the common factoring portion of this step. Then we have to look in the brackets and we say, okay, this right here is a trinomial. What kind of trinomial is it? It's not a perfect square trinomial because 12 is not a perfect square. That's not a square number. In a perfect square trinomial, you'd have a square here and a square there. So it's definitely not a PST. And when we see that there's a 1 in front of the x squared, we know it's a simple trinomial. So we're going to factor it like a simple trinomial. We're going to find the factors of 12 that subtract to 4. And you have a lot of really good notes in your factoring foldable. I gave everybody a copy of that in Chapter 5. So find your factoring foldable and use it. Go through those examples and look at the steps as well. In this case, the factors of 12 that subtract to 4 are 2 and 6. When we have factors that are multiplying to a negative number, we know it's one of each sign. So one bracket should have a plus sign in it, and the other one should have a minus sign in it. The way that you figure out which term or which factor gets the positive and which factor gets the negative is by looking at the middle term. This case tells us that we're supposed to add up to positive 4, so the bigger number, which is the 6, should be positive and the smaller number should be negative. In this question, we've taken it from standard form, which was this one, showed us the y-intercept but not much else, and we found factored form, which gives us x plus 6 and x minus 2 in the brackets. When you have that factored form, you can see that the roots of the equation are given. So we have x plus 6 and x minus 2 in the brackets. That tells us that the roots are -6, because we changed the signs, and positive 2. If from that we wanted to go ahead and graph the parabola, we're not going to do that here, but if we wanted to graph it, we could find the vertex by using these two roots. The axis of symmetry would just be the average of the two roots. So to find the axis of symmetry, x would be equal to -6 plus 2 divided by 2. So x equals -2 is the middle of those two values, and that's the x coordinate of the vertex. We could find the rest of the vertex by plugging -2 into either the standard form or the factored form to get the y value of the vertex. So that just covered two types of factoring. We did common factoring, and we also looked at factoring a simple trinomial. Next, we're going to take a look at a perfect square trinomial because it looks very similar to the one we just did. There's a very slight difference. If we were given, let's say y equals 4x squared, that's a square term because 4x squared is just 2x times 2x. And then let's say we had -12x and positive 9. This is a perfect square trinomial. There's no greatest common factor because 4 doesn't go into 9 and 3 doesn't go into 4, so there's no common factor there. There are square terms at the front and the end of the trinomial. This is 3 times 3, this is 2x times 2x. So to figure out for sure that it's a perfect square trinomial, we have to take the square root of each of those terms. So 2x and 3 are the square roots of those two terms. We check to see if when we multiply 2x times 3, so we multiply those two terms, multiply, and we double them. When we do that, we get 12, because 2 times 3 is 6, 6 doubles to 12. So it is, in fact, a perfect square trinomial. When we're factoring a perfect square trinomial, that's really the only hard step, is just checking the middle term. Then, when we see that it works out, this middle sign goes right here, in between the 2x and the 3, and the bracket squared, and we're done. When we're factoring to find the roots, and we see that there's a coefficient in front of the x, In this case, the coefficient is our 2x. When we're finding the x-intercept from that bracket, we either take a shortcut and we switch the sign on the 3 and divide by the coefficient. So x is equal to positive 3 over 2. Or we show why we got that and we write 2x minus 3 equals 0. We move the 3 over to this side, making it positive 3. And then we divide by 2 to get x by itself. It's the same answer. This bottom part is just showing you how we got that 3 over 2. The shortcut is just to take the opposite of this number. So if it's negative 3, take a positive 3 and divide it by the number in front of x. And in this case, because it's a perfect square trinomial, there's actually only one root, because any perfect square trinomial has a vertex that sits right on the x-axis. So the vertex is the same as the x-intercept. So we've looked at perfect square trinomials and simple trinomials. Finally, let's look at the complex trinomial. And a complex trinomial is a trinomial that has a first term with a coefficient. For example, we have a number in front of the x squared, and it also has a number in front of the x squared that's not factorable. So, for example, let's say we had y equals 2x squared plus 5x minus 12. The 2 is in front of the x squared, but it's not the common factor. It can't be factored out. Nothing else can be divided into all three of those terms. So this is an example of a complex trinomial. We did this a couple ways in class, and I'll show you the 2 ways that we did it. I'll also show you a shortcut that we looked at afterwards. When we're looking at this trinomial, we're looking for the factors of not only the negative 12, but the factors of 2 times negative 12. So factors of 24. Remember the sign rules for trinomials. If the last term is positive, then they have the same sign, and they add up to the middle term. Add to middle term. If the last term is negative, like this example, negative 12, they have opposite signs, and they subtract to the middle term. So when I'm looking for factors, I'm looking for factors of 24 that subtract to 5. Subtract to 5. So two numbers that multiply to be 24 that are 5 apart or that subtract to 5 are 3 and 8. Of those two numbers, the bigger number, which in this case happens to be the 8, should have the same sign as that middle term. So this positive goes with the bigger of the factors. So positive 8 and negative 3. Now in class we did this a couple different ways. Some of you liked to put the 2x at the start of each bracket, and the 3 and the 8 in the brackets, and then common factor out of 2. In this second bracket, there's a GCF, there's a common factor of 2. So we can replace 2x plus 8 with 2 bracket x plus 4. Those 2's cancel, and that's our answer. 2x minus 3 times x plus 4. Some of you did it this way and liked it that way better because it showed you why the 2 was disappearing. Others did it the way with the fractions over here on the right hand side. So instead of taking the negative 3 and the 8 and putting them in the brackets, you divided by 2x, and whichever fraction could be reduced, not this one because it's in lowest terms, but 8 over 2 reduces to 4 over x, and those two became your brackets. The first term was the denominator, so 2x went first, minus 3, and x plus 4. So that's how you got your two brackets that way. 2x minus 3 and x plus 4. Later on in the unit, actually maybe even in the next unit, we talked about another way, a shortcut that somebody took that I found was really, really interesting. I'd never seen anybody do this before, and I showed you guys in class. So if you wanted to do that, you're more than welcome to use this method as well. I'm just going to erase the bottom part here. Oh, I thought I was erasing. There we go. So when we looked at the questions in class that somebody was filling out, they did it in a really interesting way. They, instead of putting the fractions on the right hand side and reducing the fractions, they reduced them right in the brackets, which was kind of neat to see. So they did this. X, having a good time here, guys. X minus 3 x plus 8, and they put the 2, this 2 right here, instead of putting it over on the right-hand side under the fractions, they put it right here. And they reduced where they could reduce. That turned into a 4, and they moved this 2 in front of the x. It's completely up to you which way you want to use. Look through your notes, look at the way you used to do it in class, see if that's your preferred method, and do practice solving complex trinomials because it's a method that has to come quickly for you in order to find the roots. Regardless of which way you find factored form, the factored form is going to be the same. Right? This is still going to be factored form regardless of what way you solve it. When you're looking at the first bracket, 2x minus 3, the x-intercept is going to be positive 3 over 2. When you look at the bracket x plus 4, that x-intercept is going to be x equals negative 4. Because you're changing the sign of the numbers in the bracket, so the positive 4 becomes negative 4, and the negative 3 becomes positive 3. And if there's ever a number in front of the x, it goes at the bottom. So those are your two roots. Those are the ways to factor trinomials. We've gone through tons of examples of them over the course of the unit. The final method of factoring that we looked at was factoring a difference of squares. So a difference of squares example could be y equals 4x squared minus 25y squared. Actually, I'm not going to put the y in there. Minus 25. When you see a difference of squares, it has 2 terms instead of 3, and both the terms are perfect squares. So 4 and 25 can both be square rooted, which is exactly what we're going to do. We're going to square root the 4x squared, which is 2x. We're going to square root it and put it in each bracket. We're going to square root the 25 to give us 5, and put that second in each bracket. What we do to make this end up being a binomial instead of a trinomial is we put a plus sign in one and a negative sign in the other, so that when you're expanding, the two middle terms in FOIL cancel each other out. In this case, my roots would be negative 5 over 2 and positive 5 over 2. So plus or minus, if you want to write them this way, you can. Plus or minus 5 halves. Those are the two x-intercepts. Again, when you're factoring, you'll find the two roots. You can find the vertex by averaging the x-coordinates and plugging that number back into the equation. Sometimes you guys got stuck. And you got stuck when we did word problem questions involving factoring of things that were almost easier than you were expecting. For example, in chapter 6, let's say we were talking about a soccer ball again being kicked. Okay, and we looked at an equation, and the equation given was the height of the soccer ball was equal to negative, let's do t instead of d, negative t squared plus 4t. And you had an equation like this, and you were asked to find when it hit the ground, the highest height, when it occurred, or the highest height and what time it occurred at. And you looked at the equation, and a lot of the times you got stuck. And when you're stuck factoring, always go back to the main order. How do I factor? First thing I do is I find the common factor. And if I'm looking at a common factor in this question, as soon as that first term is negative, the negative is part of the GCF. As soon as you see a negative first term, that means this negative belongs in front of the brackets. Also, as soon as you see that both terms have a variable, that's part of your common factor. So negative t is the common factor. It's the GCF. When you divide by negative t, oops, that's not t, you get t minus 4 in the brackets. So what are my x-intercepts? In this case, one of them's at 0, 0, which makes sense because the soccer ball started on the ground and we kicked it off of the ground. And the other one is positive 4. So how long was the ball in the air for? This is where it lands. If we wanted to find the maximum height of the ball and when it occurred, we would have to average those two values. 0 plus 4 divided by 2 is 2. So at 2 seconds, the ball was at its maximum height. The way to find out that height is by substituting the 2 into the equation and working it out. So negative 2 squared is 4, plus 8 is 4 meters. So at 2 seconds, the ball reached a maximum height of 4 meters. This was a good part of what we did in Chapter 6. Sometimes, though, we were asked to find the maximum or the minimum values by doing something other than factoring. There's a shorter way of finding the maximum or minimum. And in this case, the best way is to complete the square. So let's look at an example of completing the square, just to recall how that works. So let's say our equation is y equals negative, let's go negative 2x squared minus 12x plus 1. Remember that completing the square means changing from standard form, which is what we're given here, to vertex form. The first thing we do is we factor out the common factor. So negative 2 is our a value, that's our GCF, and it goes in front of the brackets. We factor it out only for the first two terms. So we're going to make sure that we leave the positive 1 at the end. When we divide by negative 2 in those first two terms, we get what's left in the brackets. Now be very careful of your signs. X squared plus 6x, because you're dividing a negative by a negative there. Then we're going to hit and square. We're going to do half of 6, and then we're going to square it. Now half of 6 is positive 3. When you square that, that's what you're adding and subtracting in the brackets. So y equals negative 2 bracket x squared plus 6x plus 9 minus 9 plus the 1 that used to be there. We did half of 6 and we squared it. We didn't do half of 12 because 12 was the original number, but then we divided by negative 2 to get the 6. It's important that you divide. These are the steps that get miscalculated on your tests. Don't forget to divide by the common factor. Don't put a 12 in here. It's a positive 6. Then half of 6 is 3, but 3 squared is what goes in the brackets. Then we're going to factor and move. We're going to multiply negative 2 by negative 9 and put it outside the brackets, which is positive 18. And we're going to leave the negative 2 in front. And then we're going to factor this trinomial. It's a perfect square trinomial, so we're just going to take the square root of 9 or a half of the 6. Either you take this number and you cut it in half, put it right there, or you square root this number right here, or you look back if you wrote this down and it's just the same thing as what you copied down before. So x plus 3 squared. And then 18 plus 1 is 19. So my vertex is going to be opposite of what's in the brackets, negative 3 instead of positive 3, and positive 19. When we look at this question, we could have been asked the maximum value. In this case, the maximum is 19 when x is equal to negative 3. So that's completing the square. It allows you to find the vertex. The vertex is what you're going to find if you're asked for the maximum or the minimum value. I'm going to stop this part here and maybe do a couple more word questions in the next section, as well as some quadratic formula.